Hi there, welcome back to my channel. In this video, I'm going to take you through Jacobi method. So this is the first method under linear iterative method. Linear iterative method. Okay, so iterative method. So in this method for solving systems of equation, it deals with guessing the solution of the system before you solve. So you just guess. Then after you use the guess solution to perform series of iterations. In real life, many systems of equation we encounter are very large, so you can't use the Gaussian elimination and other methods to simplify. That is why you have to use the iterative method, which is also a very efficient method for solving systems of equation. So what do you mean by the Jacobi method? Or what do you mean by the linear iterative methods? So specifically Jacobi. Assuming that I have a system of equation, let's say 2x plus y plus z is equal to 1, right? And I have x minus y plus 2z is equal to 4. Then I have, let's say, 2x plus y minus z is equal to 3. So these systems of equation here that I have here, if I want to use the Jacobi method, all that I'm trying to say is I'll assume an initial guess. So I'll just say that the solution for this is x, y, z is giving us, let's say, 0, 0, 0, right? So you just assume that the solution for this system is 0, 0, 0. Once you have assumed the solution, the next thing is to make each variable the subject. Okay, so you make x the subject in the very first equation, you make y the subject in the second equation, then you make z the subject in the third equation. And you should make sure that you are going to get a diagonally dominant matrix. So normally systems of equation given are going to give you a diagonally dominant of matrix so that your solution can converge. So we have what we call convergence when it comes to linear iterative method. Okay, but the convergence is most useful when you reach the nonlinear part. Okay, the nonlinear. So let's see, when you have this system, as I said, the other way to apply your Jacobi method, the first thing to do is to get your initial guess. Maybe you just say that looking at this systems of equation, let me start with, let's say, 0, 0. Somebody can choose to start with 1, 1. Okay. But the goal here is to converge to a particular solution. So you realize that as you are iterating your method, your answer is keeping approaching at a particular point, meaning that will be your solution, right? Depending on number of iterations performed. So let's see what the iterations and all that means. Okay, so first, as I said, you make x the subject in the very first equation. So if it was different variable, make your first unknown not the subject. So I'm going to get this x. Okay, I'll have 2x is equal to 1 minus y minus z, right? So therefore x is simply equal to 1 over 2 open bracket 1 minus y minus z. Is that not it? From the second equation, I have to make y the subject. To make y the subject, what am I getting? I'll send y there, then I'll bring, so I get something like x minus 4 plus 2z is equal to y. As simple as that. So I'm going to get y is equal to x minus 4 plus 2z. Then in the third equation, I will simply make what z the subject. Okay, so making z the subject, I'm going to get something like 2x minus 3 plus y equals z. So therefore my z is equal to 2x minus 3 plus what y. So having make the subjects, which is all the unknowns here, the next thing to do is for me to put in my initial guess. You know that x initially you have assumed it to be 0, right? So for you to do the iterations means that you are coming to put these solutions in it so that you find new solutions for our x. Then you keep on like that. So let's see. What you're going to do is you find a new x. Okay, so you find new x. So our x will be what? Y is 0, z is 0, right? So y is 0, z is 0. From what you're having here, you simply have 1 out of 2 multiplying 1. So our new x will be half, right? Then our new y, what will be our new y? I'll simply put 0 here. I'll put 0 what? Here. It will go. So I'll get my y to be what? Negative 4. Then what will be my z? When I put 0 here, my z to be what? Negative 3. So after doing this is what we call the first iteration. First iteration, meaning that you have put in your initial guess into it and you have got a new set of values for what x, y, z. So after the first iteration, you are having x, y, and z be what 1 out of 2, -4, then -3. Then you will use these new values, you put it back again. So our second iteration, you will just simply write x is equal to 1 out of 2 multiply 1 minus the y here is what -4, right? You simply bring -4 minus the z here is what -3 in that order. So you also get a new set of values for our what? Our unknowns, and this is what we call iterations. So performing a series of this step is what we call what? Linear iterative method. The goal of the iteration is to converge. That's why I said the word convergence is of very use here. So we tackle convergence in our subsequent tutorials. So the goal of this iteration is for us to what? Converge. Okay, is for us to converge. So basically in this video, I'm to introduce you to what? The Jacobi method, right? What is it all about? It's just making your unknown the subject, having an initial guess, and putting the initial guesses in it to get new set of solutions. Then you use that new set of solution to also get new set. In that manner, it keeps on repeating until you convert to a particular point. I have a problem for us to solve here. So let's look at this. So we said use the Jacobi method to solve AS is equal to B. So this is the system. I've been given A, I've been given what B, right? So here I'll assume X to be what? X1, X2, and X3. Okay. I'll assume X to be X1, X2, then X3. So from the question, assume initial guess. So most questions they will give you the assumed guess, okay, to ensure uniformity. The assumed guess is given as X1, X2, X3 as. So let me do it in the column form. That would be good. So I'll have X1, X2, X3, right? X3 is equal to the initial guess given is 1, 2, then 5. Like this. So we have to solve this using the Jacobi method with an initial guess 1, 2, 5. So how do you do this? To do this, my approach, which I'll recommend to you, is that always write your equations in full, right? So let's start. To start, you write all the equation back again. So we are converting the matrix form into what? The equation form. So you know that this is the same as what? 25, 64, 144, 5, 8, 12, 1, 1, 1, multiplying x1, x2, x3, and this giving us our output as 106.8, 177.2, 279.2, right? So after getting this, we just write the equations down. So what do I get? I'll get 25x1 plus 5x2 plus x3, right? Then it should give me 106.8. Then I'll have 64x1 plus 8x2 plus x3 is equal to 177.2. Then I'll have 144x1 plus 12x2 plus x3, and that is going to give me 279.2. So having these three equations, as I said, you are supposed to make each unknown here. So here we make x1 the subject, here we make x2 the subject, and here x3 the subject, right? Yeah, so that's what you are going to do here. So making x1 the subject, so x1 will be equal to what? From this equation, let's see, we are going to have 106.8 minus x3 minus 5x2, right? All divided by what? 25, and that will be equal to x1. So my x1 is simply 1 out of 25 multiplying the expression 106.8 minus x3 minus 5x2. Then you put this one down. What will be my x2 in the second equation? My x2 in the second equation will simply be what? 177, right? 0.2 minus what? I want x2, so I'll just bring the rest there. So minus 64x1, then minus x3. All this over the coefficient of what? x2, which is 8. Then finally, what will be our x3? Our x3 is simply going to be, I'll send the rest there. I'll have x3, I'll make here the subject, right? So I get 279.2 minus 12x2 minus 144 x1, right? Yes. So at this point, right, at this point, what am I going to get? I'll just apply my initial guesses, then I'm good to go. So applying the initial guesses, so let's see. So the initial guess, let me write it here. I have 1, comma 2, comma 5, right? So I'll have to get my new x values. So my new x1 value will simply be equal to 1 out of 25 multiplying 106.8 minus the x3, which is 5 here, right? X3, which is 5. So the x3 is 5, okay. So minus 5 multiplying x2 is 2, okay, like this. So writing this, the answer here is equal to 3.6720, okay. Then the x2 is equal to 1 over 8 multiplying 177.2 minus 64 x1. What is x1? X1 is what? 1, okay. So 1. Then minus x3, which is what? 5. So what am I getting for this? When you punch this into the calculator correctly, you should get 13.525. Then I find my x3. Here to I'll make from this, I'll have to put in what my initial guesses. So I'll simply have 279.2 minus 12. The x3 is what? 2 minus 144 multiplying 1. This should also give me 111.2, right? So now my new set of solution after the first iteration, I'm getting what? My x11 is equal to 3.6720. X21 is equal to 13.525. Then x31 is equal to 111.2. Okay, yeah. So right now these are the new set of what values I have. Then I move on to the second iteration. So for the second iteration, I don't have to do anything different. I simply have to clean the initial guesses. So here was 5. You simply clean the 5 here, then you place it with what? Your 100 and what? 11.2. Okay. So I don't want to write all the equations back again. So I'll simply be cleaning, and you have to observe carefully. So at this point, you see here was 106.8 minus x3. Our new x3 now is what? 111.2. Okay, so 111.2. So I'll simply have 106.8 minus open brackets 111.2, then minus 5. Our x is 13.525, right? So this is the new iteration I'm writing here. So I'll clean this side, right? So I'll clean this here. So 5 multiplying what? X2, and our x2 is 13.525. And this should give us, if you do it correctly, this should give us negative 2.881. Okay. Then we come to the x2. For the x2, I have 177 minus 64 multiplying x1. So I just have to clean the old x1 and place it before the new x1. So what's the old x1? That one was 1. Then the new one is open bracket 3.6720. Then we come again with minus x3. And the x3 is 111.2. So after doing punching this correctly into the calculator, you should be able to get we should get negative 21 point we should get negative 21.126. Okay, negative 21.126. Then we come again for the x3, 279.2, right, minus 12x2. So you clean wherever you see this, let's clean it and do the necessary thing here. So my x2 is 13.525 plus, sorry, minus So minus, yes, so I have minus 144x1, which is 3 points, which is 3.6720, right? Yes. So this should be equal to negative 411.868. Okay. So now if perform two iterations, so our second values for the second iteration x1 1 1, so the prime here, I'm just indicating that it's the second iteration. Okay, so the iteration value is negative 2.881 x2 prime plus negative 21.126. Then for the x3 prime, right, going to get negative 411.868, right? So this is the two iterant values important. So the first iteration and this is the second iteration. Now in the question they didn't specify the iteration, right? So let's do up to the second iteration. So the question can ask you to do three, can ask you to perform four iterations, right? So depending on the specification of the question, that is what you do. So this is the nature of Jacobi's method. Jacobi's method. So thank you for being with me in this video, and please subscribe if you found it very useful and helpful. Then don't forget to like and also share as well.